Codeforces problem, removing smallest multiples. So problem states that we are given a set S which contains the elements from 1 to n, and then you can perform this operation of choosing some integer k such that there exists a multiple of k in set S, and then remove that smallest multiple of k from the set S. And this operation requires a cost of k, and you are given a set t which is characterized by this binary string t, and which defines it as if there is 1 present at the ith location, you don't have to remove that I from the set S, and if it is 0, you definitely have to remove it. Okay, and we have to find the minimum possible total costs. So let us take a look at some example test cases. So for first test case, the answer is trivially 0 because we don't have to delete any element. Okay, so for second test case, take a look at here. So we start parsing string from left, and we see that we have to delete 3. So we keep track of answer is equal to 3 plus, because you can't select anything less than 3. If you select 1, this 1 will get vanished. If you select 2, this 2 will get vanished. So answer is equal to 3 plus. And suppose first thing in our mind comes is that if we select I for every str of I such that it is 0, we can always get a solution, right? But we don't know if it is optimum or not. Let's check if it is optimum. For this this I, answer will be 3. For this I, answer will be 5, and for the further I, answer will be 6. So 6 plus 5 plus 3, it is going to be 14. But suppose if I choose 3 for this, 5 for this, and 3 again for this, as 3 has vanished, then 6 will vanish. So 3 is equal to, this answer will become 11. So this is definitely less than 14. So we have concluded that we have to optimize something. Okay, so what I will do is parse the string from the left. Answer is equal to 3 plus. Now I will go in the multiples of 3. So next multiple of 3 is 6, and I will keep one vector long, suppose name it helper of n plus 1 to ensure 1 based indexing, and minus 1 is to indicate that it hasn't been processed till now. So here helper of 6 will be minus 1, and if we see that we update helper of 6 as 3 because we are coming from 3. Okay, so here it will be 3. Now going forward, if we get 0 and helper of this 5 is still minus 1, so we add 5 to that directly, and when we get to 6, we see that helper of 6 is 3, so we add that to the answer, and our answer gets 11. So let's take a look at another test case. So this thing here, answer is equal to 2 plus. Now same thing, we will again maintain this type of vector here, and we will hop in the multiples of 2. Okay, but when you encounter this 1 in the multiples of 2, when we encounter 1 in this multiple of 2, you break immediately, because what will happen is that if you don't break, you will go from 2 to 4, 6 and 8. Suppose this 8th index was not 1, it was 0, then you will update its answer as 2. But when you use 2 to remove this 8, the 4 gets vanished, not the 8. Okay, so that's the wrong thing we will be doing. So whenever you find 1 while hopping like this, you immediately break and then go forward. 2, this is 3, plus then you go on to check multiples of 3. 3, 6, it is 1, so you break. Again you go forward. 4, no, this is 5, so plus 5. And no need to check for the multiples, right? Because already string size is less than 2 into 5. So yeah, and for this helper of I is still -1, so plus 7. Then answer will be 17. And now one final test case. So this covers the everything that our solution has, or properties of solution. So let's see. Answer is equal, first to initialize the variable answer plus is equal to 3. Then hop on the multiples of 3. So 3, 6, you find 1, break, plus you go on 4, you add 4, as helper of 4 was -1, right? So you go on to hop for the multiples of 4, you get to 8, still it is 0 there, and also helper of 8 is -1, so you update helper of 8 as 4. Okay, then you hop to 12, then you find it is 1, so you break there. Next, then you get to 8, but already answer has been pre-processed for this, or updated for this, so you add 4, plus for this 9, because helper of 9 is still 9, so plus. And for 9 we don't have to check for the multiples because it is already bigger than 15, so 9 here, 11, 14 and 15, 11, 14 and 15, so it is 29 plus 11, 40, 29 plus 11, 40, 49, 43, 47 and 60. So answer is going to be 60 in this case. So I hope you get the solution. And again, time complexity of this solution is like order of n plus, as we are parsing the string. And for suppose, what is the worst case, that t contains all the zeros, right? So for 2 we have to hop all the strings, it will take n by 2 operations. For 3 also we have to hop all the string, then n by 3, not exactly 1 by 3, approximately n by 3, then n by 4, plus so on up to n by n. And you know, this thing mathematically is close to n log n. Okay, then our solution is having time complexity of n log n, so which will pass in the given time limit. Okay, so let us take a quick look at the code. So this is my code. I try to keep this type def long ll, yeah, and who doesn't like it? And then number of test cases and string, and I do this thing to ensure one based indexing. I do str is equal to t plus str, then I initialize helper n plus 1 because to ensure one based indexing, and answer is equal to 0, initializing it. And yeah, we go through the loop. If str of I is equal to 1, we don't have to do anything, we just continue through the loop. And if helper of I is not equal to -1, then already we have pre-processed the answer, then we add helper of I to the answer, else we add I itself to the answer. And then that part, pre-processing thing, means hopping by I. So j is equal to 2 star I, j is less than or equal to n, j plus is equal to I. If str of j is equal to 1, then we have to break. We saw this in our cases, right? And if str of j is equal to 0 and helper of j is equal to -1, if we have to include this condition, otherwise if helper of j is not equal to -1, still it will be get overwritten, right? We don't want that. And also our cost will increase because of that. So that's why helper of j is equal to -1 is necessary condition. Then we update helper of j is equal to I, and we keep on doing this, and finally we arrive at our answer. So yeah, these are some nice debugging steps I use, which are pretty well known as well. So hope you enjoyed this video and the solution and everything. Not everything, but I hope you enjoyed pretty much all of it. For many such interesting Codeforces problems or competitive programming problems, stay tuned with our channel. Thank you for watching this video, and try to subscribe and like this video as well. See you on the board. Stay tuned.